The Commodore 64 computer was sold from August 1982 through June 1993. Over that span of 11 years, Commodore made several design revisions. There were motherboard revisions aimed at cost reduction, there were aesthetic case design changes, there were keycap color and print location changes, and there were badge changes. When Commodore first launched the C64, it was in the familiar bread bin style case with unassuming silver badge labels. Fans typically refer to these as silver label C64s. In this video, we'll be taking a look at an early silver label Commodore 64. This is a particularly early C64. The box design is familiar, with these graphics being among the most common. However, notice that this early box was created before the 1541 drive was available, so Commodore chose to depict one of their pet dual floppy drives being used for disk storage with the C64. The later boxes of this design were changed to show the C64 paired with a 1540 drive. The serial number shown on the box here is what tells us that this is one of the earliest Commodore 64s made. The S prefix indicates that it was assembled at Commodore's Santa Clara plant. Commodore's Santa Clara facility was constructed at 3300 Scott Boulevard in 1978, and Commodore took occupancy in 1979. It was a 60,000 square foot building where they began production and final assembly of PET computers and peripherals such as printers and floppy drives. By 1981, it was one of several final assembly locations for the VIC-20 computer, and initial Commodore 64 production began in this building in 1982. Over the years, Commodore produced the C64 in plants all over the globe, including at their Corby, UK plant, West German plant, and others. But the very first production Commodore 64s came from 3300 Scott Boulevard in Santa Clara, California. As I mentioned, the packaging graphics are common, but this early box is just a thin cardboard shell around a styrofoam insert. The later boxes were made from thicker corrugated cardboard with a top lid that opened and closed. The famous Commodore Chicken Lips logo is molded into the top half of the styrofoam insert. The C64 is still stored in the original plastic bag. Unfortunately, the original manuals and warranty card are not present. Back to the serial number for a moment. You can see that this is serial number 1450. It's believed that Commodore began with serial number 1000 for their first production run at Santa Clara. Pete Ritwage tracks Commodore 64 serial numbers in his C64 Preservation Project database, and thus far, no production serial numbers lower than 1000 have been registered. That would make this the 450th Commodore 64 ever produced. The early C64 keyboards had brown keys and orange function keys, just like the VIC-20 before them. The C64 and VIC-20 keyboards are interchangeable, so one must assume that in the overlapping years of VIC-20 and C64 production, the same keyboards were used for both. Commodore eventually changed the C64 function keys to a light brown or gray color. I talked about the packaging, and I showed you everything there is to see about the exterior case of the C64. I'll open it up now so I can show you the inside. The top case half of the C64 has been removed, and I also removed the two RF shields. These early C64s did not have the large monolithic RF shields, either cardboard or metal, that covered the entire board like the later C64 models had. Likewise, they also did not have the shield covering the entire bottom of the board. The very first production C64 boards all had assembly 326298 motherboards in revisions A, B, or C. This board is a revision B. The 6526 CIA, or Complex Interface Adapter chips, provide interval timer functions, a time of day clock, and 16 peripheral I/O pins per chip. These I/O pins handle things like transferring data to and from external peripherals and reading signals from the C64's keyboard. The design of the 6526 was started by Al Charpentier and Charles Winterble, and eventually was completed by Bob Yanis. These CIAs both have date codes of 1982, which indicates they were made in the 19th week of 1982. That was the week of May 10th through May 16th, 1982. 901226-01 is an 8K 2364 ROM chip that contains the Commodore Basic V2 ROM image. 901227-01 is an 8K 2364 ROM that contains the C64 kernel code. Contrary to the popular meme that claims the C64 has been in service since 1982 without needing any updates, there are bugs in the kernel code on these early C64s that were addressed in later revisions of the kernel ROM. Both of these chips have date codes of 2482, which was the week of June 14 through June 20, 1982. 901225-01 is the C64 character ROM. This one has a date code of 0583, which suggests that it was replaced at a later date, likely to fix the well-known sparkle bug that afflicted the earliest Commodore 64s. The sparkle bug was widely attributed to being a problem with the VIC-2 chip, but it was eventually traced back to an issue with the 901225-01 character ROM. These 4K programmable ROMs had been created by Al Charpentier at MOS Technology and were being sold to external customers before they were used in the C64. By 1982, there were 3 million of them in use in other applications, seemingly working without issues. On the C64, the VIC-2 and the 6510 alternated control of the system bus, and when control passed from one to the other, voltage spikes sometimes resulted. On occasion, the character ROM chip would see these spikes as a valid address, and therefore provide invalid character data to the VIC-2 chip. The result was random slices of characters showing up on the screen. Worse was that because the VIC-2 thought the data was valid, the sparkle remnants on the screen would actually trigger sprite collisions. The sparkle bug affected the first few 100,000 Commodore 64s sold, and I've not found any reliable documentation on exactly how Commodore fixed the machines that were returned. If you search the internet, you'll find various accounts that range from they replaced the entire board to there was a repair kit sent to the service centers and a number of others. In the case of this C64, it appears as though the character ROM was replaced. The 6510 is the CPU. It's a 6502 variant with additional I/O pins. This one is dated 1782, which was the week of April 26 through May 2nd, 1982. The chip on the left is the PLA, which is what is responsible for the memory map in the C64. It activates chip select lines based on address line inputs. These early revision Commodore 64s used a Signetics 82S100 field programmable logic array as their PLA. Later C64 used PLA chips manufactured internally by MOS. The 82S100 was invented at Signetics in 1975, and it was the first field programmable logic array to hit the market. Bob Yanis at Commodore wrote the logic equations for the C64 PLA. It's said that these Rev2 7E17 PLAs contain additional logic equations that aren't present in later PLA revisions, but that they are disabled. Functionally, they're the same as later revision PLAs. 7E17 is assumed to be the checksum of the JEDEC file used to program the 82S100. On the right is the famous 6581 SID chip, or Sound Interface Device. The SID was created by Commodore engineer Bob Yanis, who I've already mentioned in this video as having been involved in the 6526 and the PLA equations as well. Bob Yanis is probably most well known for the SID, but if you dig around, you'll find his name mentioned often in the same sentence as Commodore, and his fingerprints are all over the C64. This SID is dated 2082, or May 17 through May 23, 1982. The 6567 is the VIC-2 video interface chip. In my opinion, this is the soul of the C64 in the same way the 6560 VIC chip was the soul of the VIC-20. Al Charpentier developed the VIC-2 over the course of 9 months working with 2 draftsmen and 1 CAD operator. The VIC-2 was a follow-up to Al's work on the original 6560 VIC chip that provided sound and graphics for the Commodore VIC-20. Finally, I would be remiss if I didn't mention the RAM over here. There are 8 4164 dynamic RAM chips, providing the Commodore 64 with a total of 64K of RAM, and the reason for the Commodore 64 being named Commodore 64. These ones were made by Mitsubishi, and they're all still original and working. In fact, every component on this board, aside from the character ROM, is unchanged from the day it was built in 1982. C64 production began in June of 1982, and the latest chip date code on this board puts it at June 1982. It's not possible to know the exact manufacture date to this C64, but the chip dates guarantee it could not have been earlier than June 1982. It wouldn't be much of a demo if I didn't show you the C64 working, so I'll do that now. I'll be connecting it to a Commodore 1701 monitor. The early C64s had 5-pin video connectors that provided for sound and composite video, as opposed to the 8-pin video outputs of later C64s, which separated the chroma and luma signals and provided for a much clearer picture. I'm connecting a 1541 drive from my demo. The 6-pin IEC serial connector was unchanged throughout the life of the C64. The power supply connector, likewise, is the same across all C64s. Composite video cable connects to the front of the 1701. Yellow is video, white is audio. They're marked on the front of the monitor for you. Looking at the back of the 1701, you'll observe that if you have a more modern C64 with 8-pin video, you can connect the separate chroma and luma here. They call it Commodore video. The signal select switch determines whether the 1701 will display from the front composite input or the rear Commodore video input. I'll have to set this to front. I'll demo the loading screen of Epyx World Games because it was the front of my disk pile, but it's enough to show off the sound and video capabilities. I'm going to end this video with a wildly unscientific comparison between that early revision C64 and this more modern 64C you see here. The big difference I expect you to notice is going to be in the video quality between the early revision 5-pin video and the later revision separate chroma and luma. The other thing that you're going to be able to hear the difference is in the SID chips. The early one has a 6581, this has an 8580. Myself, I can't tell the difference. They sound identical to me, but there are religious holy wars on the internet, so judge for yourself. All I've done is I recorded the exact same opening for World Games on both systems, and then I interspersed the video and audio together. So when you see the early 64, that is the 6581. When you see this 64C on the screen, that's the 8580 SID playing. The video is directly taken from a camera. There's no video output feed anywhere. Likewise for the audio. I just recorded everything through the same Shure microphone at the same volume levels using the same 1701 monitor. So have a look. I hope you enjoy.